Yeah, so hello everyone. Welcome to this first tutorial of the year. We'll be looking at D3.js. So as I mentioned, if anybody wants to follow along, make sure you grab the documents that are currently on the screen. They're linked on the Links website as well. So D3.js, what is that? It's a JavaScript library which allows us to do a bunch of neat diagrams. So here's sort of a showcase of all the things that it allows us to do. I'm showcasing first because we won't be doing any of that. What's important is that D3 basically consists of two parts. A lot of helper functions which allow us to do all these neat diagrams by magically placing things for us, but they all rely on a same core element of the D3 library, which is the one that allows us to interact with the web page to actually show these things on the web page. So D3 is a low-level library, which means we do need to do the sort of DOM level, web page level interactions by hand. And the helper functions are there to help. They will not do the work for us. So if you look at sort of the D3 library, visualization library I've shown here, a lot of them are helper functions, and then there's the D3 selection, which I'm highlighting here, which is actually the core which everything relies on. Basically, that's the submodule which allows us to interact with the web page, and everything else is helper functions to make it easier to obtain certain effects. So what I'm going to be focusing on today is D3 selection, understanding how we manipulate the DOM with D3. And then once you have that, everything else is very easy to use. It's just adding in small functions that do what you need. But I didn't want to get lost in sort of going through all of these, which work differently. The real important thing you need to understand is how to manipulate the DOM. So don't be surprised if at the end we don't do any of this. It would be the next best thing. If I have time, I'll sort of showcase some of them and how you would incorporate them in the code I've already presented. So there. Now let's start. So if you've downloaded the files, there are basically 5 files. There's the markdown, so basically the tutorial itself, a web page, a style page, a library I've provided, which basically gives us data content from which to work, which is what we are interested in. But when you do build a page with D3.js, you do need some data to work with. D3 stands for data-driven documents, and the idea is that we're going to be building DOM elements. So, for example, most often SVGs, based on a data set or a data model. And as that data evolves, we are going to have the SVG evolve. So deck.js is just the data that we're going to be using for this tutorial. And the important file is draw.js, where we're going to be putting all our code. Draw.js is currently empty. Quick look at the HTML page. This is really, there's nothing here. We include D3.js. So this is just the grabbing D3.js online. Our deck.js, which is our data, and then our file, draw.js, which we're going to be working with. The only important thing is we have a main tag here, which is we're going to be targeting to insert content. Deck.js.
So just a question: is it normal that when we open index.html, we have nothing?
Yeah, because currently we are drawing nothing.
Okay.
I have index.html.
Okay.
Here.
No,
as we add things in draw.js, index.html will start showing things. But as you can see, it's currently empty, so it's normal.
Okay.
And our data set, just so we know, so I should probably have said this, we're going to be drawing a deck of cards. So our data set is a deck, which is an array of value and suit objects. I also have a separated deck, which is a double array of size 4 by 13, which basically splits the deck in 4 hands of 13 cards. So these two are sorted. I also have 2 functions which generate randomized versions of these 2 data structures. And play randomly, we'll get to that later on, but creates a bit bigger data structure where we basically have a whole game of cards unfolding. We'll see how that works when we get to it. So this is basically what we're exposing through this file. And we can now start working in Draw.js to sort of draw these. So how do we work with D3? D3 exposes one object, which is called D3, which is going to be sort of our main tool to work. Basically, the whole library is hidden behind that object. D3 allows us to manipulate the DOM and bind data to it. So if you're used to other libraries like jQuery or even straight JavaScript with get element by ID, for example, this is sort of the main selection part, but we'll see that it goes a little further than that. So as I said, in the index.html, we have just a main for now. If we want to sort of see how we manipulate the DOM with D3, the smallest example is probably something like this, where I'm going to select the main tag, add an attribute to it so that I'm manipulating the element itself. And then, that worked. No, that did not. Give me a sec. There. So, what? Something is not working right. Is my keyboard all messed up? No. Sorry, debugging in progress. There. So here I've basically selected my main tag, added an ID, so you can't see that here, but there's an ID and added text to it. This is the typical way you would manipulate the DOM with D3.js.
So just to check, but until now you could have done that with a $sign particularly or something like that.
Yeah. We'll see that the power comes later when we combine that with joins. But this is sort of first thing, manipulating the DOM. And if you look at the HTML under it, so you have this. We can also append nodes. So here I'm appending a div inside of which I'm going to be putting my text. If you look at the outputs, one of the interesting things is, for example, the comment I put in the text is going to stay here because I've only appended the div to the main. Another important thing I want to point out, because it's going to start working. It's going to start appearing a lot, is D3 works with method chaining all the time. To try and make it more readable, the coding style that's often used is making blocks through indentation. We'll see when we get to bigger code that if you don't indent intelligently, it becomes unreadable. So don't be, there's no semantic meaning to it, but it's helpful. So I've shown you how to manipulate a little the DOM, but as I said, the important thing is more when we start binding data to that DOM. As I said, D3 is about building a DOM based on a data structure that is provided. So if we want to, for example, display a deck of cards, we have the deck that's exposed by deck.js. We're going to use this code. I'm going to first put it in, and then I'll go through it. I want us to see that out. Sorry, this is Teams getting in the way. So here's an example of code which would print this. So again, I'm selecting the main. This is my entry point. I'm selecting all its div children. Now, by default, the main has none. So you may be wondering, why am I doing that? I'll get to it in a moment. I'm selecting the data as being the deck of cards. Then I'm doing a join. This is basically binding my divs with the data entry inside the deck. So the deck, if you remember, is an array of objects. Now every div in main is bound to one object in that array. And for every div, I'm going to do stuff. So add a class and add text. And every time, instead of giving a value, I can actually give a function whose input is actually going to be the object bound to that specific div. So here I'm saying for every div bound to an object in the deck, its class should be the suit. And for the text should be suit plus height. And you'll see that if you recall, my deck object is here, suit plus height, you can see it showing up. And the color is actually added by the class. If you want to look at the CSS based on the class, so the suit, I'm changing the color. Feel free to interrupt me if there's a question. So this is starting to look a bit more magical because we could achieve this classically through loops, but there's actually a real binding going on between the data and the DOM. And what's really interesting is going forward, we'll actually be able to update the DOM as data updates without recreating, something you couldn't easily do with loops. And this is where the power of D3.js really shines through, is when we start updating the DOM over time as data changes. I'll get to that before a few more elements regarding just data selection and binding.
Question: if you add more divs than elements of data, remaining div would have been discarded?
I haven't added or removed divs. I'm telling D3.js, well, I'll get to it. I'm telling D3.js, every div in your main is bound to an element in your data set, and D3.js is the one that created the divs. There were none. I'll get to the update part, but D3.js will update the divs, including adding or removing divs as the data changes. And we'll see how that works and how we can actually control that to have nice effect. Nesting. Suppose I wanted to do, for example, a table so that I would have suits and cards in a table. So here I would take the separated decks. Remember, this is an array of arrays where we have the 4 suits, each in one array. And I want to do a table. The aim is to have as output for each row all the cards in that row. So here I'm actually having 2 nested levels. And the code I'm going to use, which is here, is, so in the main, I'm going to append a table. Here, I'm going to do a first join where I'm going to select all the lines in the table, bind them to the elements in the separated decks, so to the 4 arrays, each one corresponding to suit. And then join this, and then do the same thing inside each array, inside each line, where I'm going to select all the lines. The data here is going to be the element inside each sub-array. You have to think it through once. And then I'm just going to add the text as I did before. So if I do this, I should get my array. I didn't add the classes here, so we lost the colors. Not an issue. If I actually wanted to just add the class, as I did here, it should work. Perfect. Is that clear for everyone?
Sorry to interrupt. Can I have a question?
Go ahead.
So here you're using separated deck, But I mean, this is just JavaScript code, so isn't it possible already to separate the data from the original deck? So just based on the class or based on the suit, sorry.
So D3.js tends to mimic inside the DOM the structure you provided. If your initial structure is just one array, it'll tend to have one collection of tags. It's easier to sort of create your data structure in the way you want it to be represented, mirrored inside the DOM, and then D3.js will allow you to mirror it really quickly. If you wanted to use deck instead of separated deck, you wouldn't have an array of arrays. Remember that separated deck is an array of arrays with the different elements. You'd have to have D3.js split this based on class to allow for the nesting, which would be a little more complicated.
Mm-hmm.
I don't know how you would actually want to do it. I don't know if that answers your question.
Yeah, my question is, you always need preprocessing to put the data how you want to display it.
Yeah, basically your data, the D3 mirrors, has the DOM mirror the data.
Mm-hmm.
However, for a lot of use cases, some of the D3 helper functions, there are two types of helper functions. I'll get to that later, but basically, some of them manipulate the data
Mm-hmm.
to make it in the form you need. So you can sometimes have data which is not the one that D3 expects, not the one it wants, but helper functions will do that transformation for you. There are a lot of cases where that's what happens.
Okay, thanks.
No problem. Yeah.
So in building on that question, you could have one array of 4 suites, one array of 13 eggs, and then on the fly do what you do to do a sequential or parallel display.
We would have one array of 4 suits, one array of
and then proceed with
yeah. Generally, when you use D3 to show data, there will be a data processing or data manipulation phase where you just shape the data to sort of mirror what you want to show, and then D3 will consume it and mirror it properly. You'll generally have both. Sort of here the data creation and processing is something I did in deck.js, but it's pretty much, yeah.
Just a way to figure out the platonic ways of doing things, how we translate.
Yeah. There's shaping your data and then displaying it. And if I have time to get to the libraries that are the modules that are built into D3, some of them manipulate data in very weird ways. Moving forward, so I did nesting. There's also the problem of creating complex elements sometimes. So suppose you wanted for each card to have a div with the class of the suit on the div, and then inside 2 span tags with to show your suit, sorry, to show your card. Here you need something a little more complicated. You actually need to construct. So select D3, do the binding for the deck, add the class. This has just created this tag. Now the output here, we're gonna use it twice to append both spans. So here we start having a more, because if I append here and then append again, I'll be appending the second span inside the first one rather than after it. So you do need to split your operations like that. We'll also notice that I'm setting an attribute directly for things like style or even classes. In fact, you have helper functions to do things more directly. Namely, if you have multiple styles at once, here it will append the styles, where here you would override it. So we have quite a few helper functions in that regard. But this code here, does exactly this, where we can see that we are underlying the suit and putting the card value in bold inside the. So this is sort of all the DOM manipulation elements that we need to know. Now I want to focus and move on to bindings. One of the interesting things is what happens if I run my code twice. So this is just to remember, this is my basic original code, which just puts everything with the suit and the text. If I run it twice, you could expect the append to happen twice. And so I should have the deck twice. But I don't. I only have it once. As I said, D3 updates the data structure to mirror the data set. Here, the data set is the same. So when I'm running this second piece of code, it's selecting all the divs, it's selecting the deck, and it's saying, I've already got a matching. I don't need to insert or remove anything. I'm not changing the DOM in any way. This is where the magic starts to happen. And here's where it's also interesting to understand what these three functions do. So data obviously designates the data we're going to be using, the data set. An important thing is we want to be able to identify for each tag in the DOM bound to a data item what that data item is. So sometimes it's really convenient to be able to define for each data item an identifier that D3.js can use to always identify that item. You can specify the identifier with a second argument to data. If you don't do that, by default, D3 will use the index in the array. So if I have an array of 5 elements, and then 5 elements inside the DOM, first element will be bound to first element, and so on. But if I remove a middle element, then afterwards I have 4 elements, 5 elements. D3 will remove the last one because it's using indexes. If I specify an identifier, it will know which one to remove. So this is something you'll see me doing a lot. So that's for data. Select children, again, it's when you want to do a bind, you need to select the tags and the data. So this just selects the tags. Not much to it. But then join comes in. So join, I'm repeating the tag type. Join is actually, sorry about that. Join is actually a shorthand when you use it this way. Normally, the full syntax is 3 functions, 3 parameters. What do I do when a new element arrives? So this is when I have a data element in my data set, which is not in my DOM. Update, which is I have a data element and a corresponding DOM element. Do I do anything? And on exit is I have a DOM element for which I have no data element. And the shorthand we're using here basically says, if I don't have a DOM element for a new data element, I'm just going to append it. If I already have one on both sides, I'm not going to do anything. So I'm just returning the element, but not doing anything. And if I have a if I have a DOM element for which there's no data element, I'm going to remove it, which is really the basic syntax you're expecting. And this is why you need the name is join needs to know what it's inserting if something is new, which should be exactly what you selected. But we'll see later on that we'll start using these functions and it'll be more complex. So here's a little more complex example where I'm going to animate over time the cards I'm displaying here. So I'm going to do the same. Okay, it doesn't like when I do highlighting. What? I'm going to use the same code here. So select my main, select my divs, data. And here I'm going to change these 3 functions a little bit. When something new arrives, the text is going to be suit plus height plus a big arrow. And when it was already there, I'm actually removing the arrow and resetting the text. An interesting thing with join is if I do stuff afterwards, the selection that I have at this point is everything that was new or already there. I no longer have access to anything that has been removed. So here we have basically a merge of new and updated elements. I put this inside a function, which I'm going to call many times. In fact, what I'm going to do is I'm going to grab a slice of my deck of size 10. And every 10th of a second, I think, I'm going to update my selection with moving the slice onward. So what's happening is I'm adding and removing elements over time. The arrow shows what the new element is, and we saw that all the elements removed. I'll do it again. So here I'm at every time step, the data that I'm passing to update is 10 cards that are moving down my whole deck. Of course, at the beginning and the end, I have less than 10 cards. And this is where we can see that in 17 lines of code, I actually have an animation for an evolving data structure, which is really easy to set up. Is that clear? I'll take that as a yes. So here, we're going to move on. I've been using just simple divs for now, but most often D3.js is used with SVGs because that's where we have the animation. So to begin, we'll build an SVG. So here's the HTML we're aiming for. I'm going to try to have one group per suit. So we're going to be using separated deck. One group per suit. And in each group, I'm going to have each card be a white rectangle, the suit, and the height. So I don't want to go too much over the details, but this is sort of a combination of everything we've put up to now. I'm going to create the SVG. I'm going to do two nested bindings. So one for the hands for the suits and one for the individual cards. And for each card, I have to have a complex structure. So I have to reuse a given group and append multiple items to it. But combining this with the magic of CSS, I should already have. So green is my SVG, and here, why I only have one card is because I actually have 52 cards which are stacked on top of one of each other. I haven't placed them yet. More specifically, I've placed the rectangles and the texts relative to each group for the card, but I haven't placed the groups. So some placement has happened, but not the rest. Now we're going to move that around. So as I said, rectangles and text here, I've been placing them with X and Y. Groups, you can't use X and Y to place them. You have to use the transform attribute. So this is SVG specific stuff. But we're going to move these around with D3.js. So I'm just checking what I'm doing. So here, once I've joined the first group for the hands, I'm going to move the hands around. So the suits. Yep. This should already place the suits around. So I'm doing a rotation and a translation inside the SVG. I've placed each suit group. Now I need to place the cards inside the suit groups. This is the same thing. Each time I'm targeting the newly created items for that card. One thing you want to notice here is up till now, I was using a function which relied on the data object to, for example, grab the suit. Here I'm writing functions that use the second argument instead. The second argument is the position inside the array. So here I have an array of 13 cards, and I'm using the index inside that array to translate differently for each card. Same thing for the rotations. I'm using the index inside the 4-suit array to decide if my rotation. Now here the 6 is due to the fact that I've hard-coded the length of that array. But as we start working with variable length hands, we're actually going to use the third parameter as well, which is the array itself, to actually grab the length. So this won't change anything, but here if I change the length of a given given hand, if you think of this as 4 hands, things will be centered automatically according to that length. So that's just the setup of displaying the cards inside the SVG. Now we actually want to sort of start updating this and animating this. So we're going to update the game. Here we're going to start using the function. So I've been using separated deck here. As I said, we could use some of the helper functions I provided, which I'm forgetting to use. If I wanted to generate random hands, so a similar data structure but randomized, it should work, and I would get a randomized deck relative to 4 hands. As we want to animate this, I'm actually going to use play randomly, which is going to give me something a little more complicated. Rather than give me one data structure of that type, it's going to give me an array of data structures in which for each item in that array, the data structures will have smaller and smaller hands. So what play randomly is going to return is an array of structures inside of which I'll have 4 hands with at first 13 cards, then 12, 11, etc. So at each time slot, for each element in that array, I'll have smaller hands size reduced by 1, and they'll be compatible. So basically, we're removing a card in each hand at each iteration. And that's how we're going to want to update our game. However, to do this, we need to move things around a bit. So first thing I'm going to do is SVG creation. We're only doing this once, so I'm moving it outside. And this is going to be the source of my selection. So now from here on, I'm starting off SVG, which is not going to move. And then when I update the game, I'm doing exactly the same code I did as before. And the magic will happen in the fact that the positioning depends on the index and where I am, and on the fact that elements will be magically removed. So I'm going to copy this. This is basically the same code inside a function. And here, so I'm grabbing my game, which I've generated, and for each set of hands inside that array, I'm going to wait before updating to that set of hands. So here I'm putting 1 second between each iteration, and you'll see the hands appearing, and every second I'm removing 1 card from each hand. I'm updating with a new data structure that has 1 less card per hand. And D3.js is doing what I expect it to do. Is that clear?
I have a question.
Go ahead.
Yeah, can you show the HTML code from the browser?
Okay, so I'll even show it with stuff going on here. So here, if I look inside the SVG, you'll notice that I'm removing. Is this what you want to see?
Yeah. So actually, it is building an HTML code for at each iteration.
Not quite.
No.
And we'll see this as we start animating things. It's removing or adding elements. If you come back here to how the join function works, it's adding new elements, not touching existing ones and removing obsolete ones. But it's not rebuilding the SVG at each time. It's only touching those elements which change. It's not a full rebuild. And this is going to be very important when we start animating things, because for elements which were there and stay there, but need to move, as will be the case in our case where the hand shortens, that HTML entity is going to remain there and is going to move around, which you couldn't do if you were recreating the HTML code each time, the DOM. So we're really manipulating the DOM entity by entity rather than rebuilding it each time. That's better for performance reasons, but it also allows us to really have a more dynamic approach. Does that answer your question?
Yes, thank you.
Yep. So before I start animating this, I just want to point something else which we didn't see, but we should have seen here. If you look at what's happening sorry, I have to open it quick. Inside one of these, you'll notice there's a lot too much stuff. Actually, my groups here, I'm appending each time I call the function. So I'm actually inside the card group recreating the three things inside of it, the rectangle, text, and suit, every iteration. So at the end, the last card actually has 13 cards, identical cards piled on top of one another. I shouldn't be calling this every time. I should only be calling this on creation. So what we're going to do is create the function that creates the card, call it enter. Basically, we're going to update join with enter, update, exit. Update, exit, we're going to take the default ones, and we're going to create our card properly inside an enter function. I just have to check. Here, I'm defining my enter, update, and exit functions rather than doing all this work here. We also, inside enter, have the class. Notice that the class is set only once and it's always the same, so I don't want to reset it every time I update. However, the transform changes, so I do want to change it at every update. Remember that what happens after the join is applied to both updated and new elements, which is what we want. But here, I'm only creating the card once, and if I go back to the DOM, too late to open it, but if I go back to the DOM, we'll see that the card only exists once. I don't have that sort of piling up happening. Is the difference clear for everybody? I'll take that as a yes. Okay, so now we want to animate cards. So for now, this transformation happens instantly. So I'm changing the transform attribute of the card group to move it. What I want is to transform to change that transform dynamically, have a transition over time where it moves. So for this, I'm going to use the transition method, apply a duration to it before doing that transform. So what I'm saying is whatever happens afterwards, I want you to apply it progressively over time. So this is 500 milliseconds. So if I just do this, normally I should already start seeing stuff happen where the positioning done through transition is updated over time. Now there's a lot happening under the hood. Namely, D3 is capable of extrapolating the intermediate values between what the original transform was and the final transform is, without me having to tell it anything. For more complex transitions, it does need to be helped, and there's a bunch of D3 transforms that help you specify how you want that transition to happen. A common example is if you have things on, say, a circle, and you want them to move along the circle, if you just specify the start and end position, it will cut through circle to go from start to end, but it's possible to specify how the transition should happen so that it stays on the circle. There's a lot of other same thing. If you're transitioning colors, you want to change the hue without going through the color cube. So you have functions that allow you to do that automatically. But that's for just starting to do transitions. We're going to add a bunch of transitions to see sort of how these work together. So for now, if I rerun it, we have positioning of new and updated elements, which were fine. You can see that disappearing elements are just still removed instantly, which is kind of a shame. So now we're going to work on the exit function to try and have those cards disappear more smoothly. And in fact, we're going to have the cards be played and then disappear. So inside the exit function, which was initially return element dot remove, we're going to have a transition. We're going to take half a second to actually move that card to the middle of the table. And then another transition, which is going to be applied after that, which is going to set its opacity to 0. So basically, we're going to have the card fade away. So this should replace the content of my exit function. This is a transition I'm applying on exit. Oops. And now we should have cards played in the middle and then fade away. So I have one transition happening on enter and update elements, one on, well, two on exit elements, but we can go a bit further. When we deal the cards in the middle, same thing, have them appear near the middle and move to the hands to show that we're actually dealing the cards. So this is going to change the enter function, where I'm going to have, so here, what's interesting is when I create the card at the beginning, currently, I'm just adding a class to the group. I'm going to set an initial opacity and transform, say where the card starts. So this is sort of giving it a starting value before the transition. And then when I do the transition here for new and existing elements, I'm going to send it to the right place. So it's just not going to start in the same place. It's going to start somewhere in the middle before moving. But I also want to say, hey, you started transparent, but I do want you to appear in the hand. So we do need to change the opacity as well. And now we should have the hands being sorry, the opacity should be, everything's happening fine, but I should tell it 1. And there we have it. So now the hands are dealt out properly, cards are played properly, the hands are reduced properly to the right size, everything's happening smoothly, and that whole animation is 60 lines of JavaScript. That's most of what I wanted to say. This is basically how your general D3 structure, your D3 selection methods are generally structured. You have an update function. You create the basics which won't move throughout the lifetime of your graphic. You have an update function, which is what you'll call every time data changes. And often you'll have one enter, update, and exit functions to say how you want data to, so how you want the DOM to evolve as data changes. And that structure is going to be the same in most applications. And then inside your update function, you'll have possibly nested joins. If you have nested joins, you'll sometimes have enter, update, and exit functions at different levels. So you could have, if you had a variable number of hands, not a good example here, you could have weird enter, update, exit functions here and here. And then you sort of need to think what happens, because when I enter here, there'll be some enter here as well. You need to think how they work together. But that's the general structure you'll have in most applications of D3.js. I just want to go over some of the things I didn't cover real quick, which can allow us to do a bit more of the more advanced selection techniques in D3.js. And then how long do I have? I can either do that or show more of the helper functions. Try to do both really quickly. Call. So there, I want to go over 2 important functions in D3.js for code reuse. Call is a function which will allow you to apply a function to a selection. So here, if I want to reuse part of this code, For example, the one we used at creation, if I, sorry, never double click. If I want to use code, the same code in multiple places inside my D3, the same data, sorry, the same function chaining in multiple places, call will allow me to basically do that by chaining things on an element inside a more complex structure. So in my code, when I was doing things like separating the enter function, sorry, even before that, give me a sec. When I was doing nesting, yes, when I was not nesting, complex, where is it? Here. When I'm doing things like this, if I want to use this code multiple times, I can do a call here to a function which will apply this inside this chaining. So it allows us to help structure code and reuse some building blocks if we have different elements we're using in different places. So in my case, there's not a lot of okay. One of the other use cases is obviously debugging, where you can just call a function on your data to do console log, see what the data is at a given point in your code, in your data chain, if you're not sure. The other one is each, which will allow you to call code on elements of the selection. I don't want to go into the details because you need to use it to sort of see the difference. But I don't know how to explain this easily. You don't have access to quite the same data. Call is really useful for chaining functions, which will be basically D3 functions. Each will give you more access to specific DOMs and datums and data, sorry. Basically, depend. Inside each, you'll restart a selection with D3. I don't really know how to explain it. You have to use it to explain it. I probably should have prepared that a little better. Is there a good way to? Each sort of resets the data flow of D3.js, whereas call does not. Yeah, you need to know the two methods exist, and the one you need is hard to decide with a fixed rule. There's other functions to change the data flow, datum, which allows you to change data. Merge for merging selections. In cases where you would have a D3 selection, and you want to merge them. You can attach event listeners, which means you can have SVGs which will react when you click somewhere. And so, as I said, a bunch of utilities. Do I have time to go over a few examples? Yes. I just want to sort of go over examples and sort of show how things work out. Utilities. Okay, here are things which we can build with D3. And I'm sort of want to, I'm going to let it build so we know what we're talking about. Let it compile. Thank you. So if you have a graph system, for example, this is built with D3. So your input would definitely be a graph structure. D3 is going to provide, if we look at the code, a force simulation module. And what's basically happening is this is going to change your data structure and insert coordinates for each of your nodes. So you're going to have D3 changing your data structure to provide coordinates, and then classical D3 selection code similar to the one we wrote. I won't go through the code in details, but you should be convinced that if D3 can compute the coordinates of the nodes for you, then updating their position with D3 is trivial, which is why selection is really core. The selection module, which I showcased, is really core to what we're doing, to anything you're doing with D3. The rest of the magic is more about touching the data structure and reorganizing it intelligently. For maps, and namely projections, I think D3 has a library which, given longitude and latitude, will give you coordinates depending on your projection. So XY coordinates for your SVG based on the projection. Again, this is changing the data structure, enhancing it to easily display things afterwards. I don't know all the libraries. Another very classical example is this. Here I have I'll let it show up. I have a weight for each data element inside my actually, I think you only provide a weight for each of the elements in the nodes of your tree. So this is a tree data structure. Each of these has a weight, and D3 will automatically compute the weight of the parents and the root and compute XY coordinates for each of those rectangles. So again, enhancing the data structure with coordinates and then you do your D3 stuff yourself. And it probably also provides a color scale. If we look at the code, yeah, you create a color scale which will automatically be applied. So D3 helps you choose the color so you don't have to worry about it. Hierarchy is the data structure, is the module used to create these sort of diagrams. And then it will define X0 and Y0 fields on your data structure, which you can directly then use in your SVG render. And so on. I could go on for a while. There's stuff for colors. Wait, sorry, this one's on. So force is the one which allows dynamic force things for graphs. There's colors, interpolation if you want smoothing or not when you're doing transitions. If you're doing things with axes, you have an axis library which basically puts the axis for you. You've got geographic stuff. All of these things are there to help you build with selection your graph. So I don't have time at all to cover them all, but you've got a lot of things that are built in. And that's basically gonna sum it up for me. If anybody has questions, now's the time.
I have a question. I don't want to monopolize, but if there are no other questions, it's quick.
Go ahead.
So in this example, so the data was already there. It was fixed. How does it go with real-time data? I've seen that you can generate it on the client side, but this means that basically in your browser, you need to have the data already. Is there a way? No?
Really, no. So I can give you a use case I've had in the past. So I'm gonna show the code for the deck.js, which I use to generate the data, if I have access to it. So if I use deck.js, let's bring it here. So the data structure at the end, can I actually show it easily? So yeah, here I'm generating the data clearly inside the browser. In the past, I've had stuff where I was doing simulations in a Python server, and the browser was connecting to the server, and every time there was an update in the structure, grabbing that data structure from the server and updating it locally, and it only ever had the current structure. It wasn't even storing it. It was just grabbing the data structure, doing an update with the D3.js code I provided, and not even storing the structure it had, the data structure, and just waiting for a new data structure. So here I had a simple example where everything's in the browser, but when you call update, so when you define your update function, so update game, you're just passing the new data structure you want to replicate. You don't need to know what was before, what comes after, and you can dynamically grab that from the server in most applications. It really depends on your use case. For graphs where you could, for example, grab a node and move it around, you would, if you have a static graph structure, it would be in the browser. But sometimes, I mean, you could have on-click events where you click on a node, it's sent to the server, who does an update, sends you the new data structure, and that will work.
Yeah, but I mean, the periodicity or the event that generates the update is always local, in the sense that you can fix, for instance, the update game every seconds, and you ask for...
So here I'm calling it with a set timeout.
Yeah.
So I'm calling it every second, but I decide when I want to call it. If
Yeah,
I were
yeah,
to do
so sorry, it's just that you, as a browser, in the on the client side, you have to ask when you want new data, because there's no way, like, for the server to push notifications to
WebSockets.
WebSockets, yeah.
I've always done that with WebSockets.
Mm.
So, and in JavaScript, namely, I tend to use Socket.io, which has a Python server implementation, which makes it a lot easier. But yeah, if you're using Socket.io for WebSockets, setting up the connection and calling update game every time the server sends an update is maybe 10 lines of code.
Yeah, thanks.
It's really easy. But yeah, that's definitely how you would generally do it. If you're running a server, you would set up a WebSocket and have the server send the data through the WebSocket every time there's an update. And then you're listening on that WebSocket, and when you have an update come through, you call your update function. Anybody else? Or not else? Nope. Okay, well.
Okay. Thank you very much.